Hey, how's it going? So today I'll quickly go over my solution to the LeetCode 72 edit distance problem. So given two strings, word1 to word2, return the minimum number of operations required to convert word1 to word2. You have the following three operations permitted on a word. You can insert, you can delete, or you can replace. So if you want to transform horse to rose, let's see here, horse to rose, it says that you can replace H with R, and then you can remove the R here. Oh, sorry, from horse to ROS, and then you can remove the E, so that in three operations you can transform horse to rose. So this is a DP problem. So the more DP problem you do, the more likely that you will realize it can be solved by a DP problem. The algorithm actually is very well explained by someone named back-to-back SWE. So I'll link his video down below. You need to pause the video if you don't understand the algorithm yet. Again, you have to pause the video if you don't understand the algorithm. So basically, we create a 2D DP array, and we initialize the 2D DP array. So first of all, we create a 0. We initialize the 2D DP array as all zeros, and then we have a buffer. So basically, we create so the number of rows is gonna be length of word 1 plus 1, and the number of columns will be number of the length of word 2 plus 1. The reason we initialize it one more row and one more column is because we need some buffer, so that when we actually fill out the DP array, we have some buffer to the left and to the top, so that it's easier for us to do something like a DPI minus 1, J minus 1. If we don't have this buffer on the top and left first column and first row, then it's impossible to subtract something like this. Okay, so first of all, we initialize the DP array. So remember, all our numbers were initially zeros. So for this first column, we are asking if we want to have we have a horse and we want to transform it into empty array. How many operations? Of course, 5. We need to delete 5 numbers. And if we want to transform HORS into an empty array, how many operations? Of course, 4, because we need to delete HORS, so on and so forth. That's why we initialize our first column as 1, 2, 3, 4, 5, like this, 2 lines. And the same goes for the first row. For the first row, we are asking if we want to transform an empty array into R, how many operations? Of course, 1, because we need to add R. How many operations from empty array into RO? Of course, 2, because we need to add two characters, R and O. How many operations we need to transform an empty array into ROS? Of course, 3 operations, because we need to add ROS 3 characters. So that's this step. Initialize the first row and first column. Once we're done with that, we need to fill in the blank of this. So basically, we go over from row 1 to n, from column 1 to column m. So if our words matches, So for example, here our O and here our O matches. We just need to get this diagonal value. Why we can get the diagonal value? Let's see. Right here we have RO, right? And we want to transform HO to what? To RO. So right now our index, the last position matches. So the last position matches, so we can ignore this because they are matches. So they will not add another operation to our result. What's before our O is important. Whatever the result, like whatever this string H and this R will be our result, right? Because O matches, it doesn't really matter. So that's why we get the diagonal value. So that's why I say when they're matches, my dpij is equal to dpi minus 1j minus 1. Basically, when they're matches, I just need to get the diagonal value. Again, the algorithm is more detailed, explained by someone named back-to-back SWE. So, and I linked his video down below. You should go to watch his video first. Okay, I will go on. So if they're not a matching, I can again insert, delete, replace, right? And this is 1, and if they're not matching, my dpij will become 1 plus minimum of I minus 1j minus 1 dpi minus 1j dpi j minus 1. Basically, I'm saying, so for example, for this HO to ROS problem, right now I see my O and S doesn't match, right? My O and S doesn't match. What I'm saying here is that I can just get the minimum of the left diagonal and the top value and just need to add 1 to it. Why? Because we are calculating the minimum distance and this diagonal value is replacing. So basically, for this HO and ROS problem, if I get the diagonal value, then it means replacing, because I'm saying that I don't care about the last. I just care about the H and RO. So basically this number, and I just need to replace O to S, right? So that's why the diagonal value means replacing. And the top value means deleting. So basically, you can see that again, HO and ROS. HO and ROS. If I look at the top value, which means H and ROS, basically I'm saying that I can delete these operations. That's why I'm adding 1 to it. And whatever H and ROS, whatever the operations, will be my value. So that's why the top value is deleting. And the left value is inserting. So for example, again, HO and ROS. If I look at the left value, it's HO and RO. Yeah, so basically it's HO and R. So when you look at this number, it's HO and RO, right? So basically, why this represent inserting is because I want to transform HO into ROS. So right now I just look at HO and RO. So I would insert the S at the end. So that's why I'm adding one operations as insert operations. So right now I'm only looking at HO and RO. Basically, I'm just saying that I know from HO and RO, I just need to do one transformation, right? Which is replacing. And I can get HO to, sorry, I just need to do one transformation, which is replacing my my H in the word one, and I can do the transformation. So that's why it's only one operations. Right now I'm saying that, oh, I actually have to do HO to ROS. So what I need to do is actually just needing to adding one more S. So that's why the diagonal value is replacing. The deleting value, the delete is the top value, and the insert is the left value. So yeah, and because the question asked me to output the minimum operations, so that's why I'm doing min of this three operations plus one. Plus one is because at this point they're not matched. I either have to do replace, delete, or insert.